All right, on Unit 9, FRQ Part B, number 2D at the College Board, they asked for the average speed on this time interval. Recall that for any function y equals f of x, if you want the average y value on some closed interval from a to b, the average y value will be equal to 1 over b minus a times the definite integral of f of x dx. So, we just need to find the average speed by using that formula. So it'll be 1 over 12 minus 0 times the definite integral from 0 to 12 of the function for speed times dt. How do we know it's dt? Because the indices are, t goes from 0 to 12, so it'll be dt. So our speed function needs to be a function of t. So how do we find the function for speed as a function of t? We're going to have to look at the given velocity vector. Okay, I encourage you to visualize this velocity vector. I'm not really sure where it's going to be, but it doesn't really matter, because I want you to visualize the horizontal component and the vertical component. Notice that the velocity vector has a magnitude and it has some direction. Maybe not this direction I've drew it in, but it has a magnitude and direction. And the speed is just the length of this segment with no direction. So to find the speed, which is just the magnitude of this dimension, we're just going to use the Pythagorean theorem. We've got the horizontal component and the vertical component. So the magnitude of this velocity vector is the speed, and that's just going to be the length of that hypotenuse of a right triangle, which is the square root of 10 squared plus negative t sine of pi over 4 squared. All right, there's our function. And now we can go ahead, put it into our average formula, and we'll know what the average speed is. All right, so our average speed is about 11.095, and we should get the units correct. That's going to be, I believe, meters per second. Yeah, meters per second, according to the problem.